Is it on? Great. Hi, my name's Dave Starling. I am the CTO of Seenit, which is a London-based company. I flew out here on Sunday to talk to you guys about what we're doing with full text search, with NIQL, across video. So what can we do with video that is interesting with search? I'm also one of the developer experts, as Brant was saying earlier. It's a program that is run by the Couchbase advocacy team, the developer advocacy team, and it gives you a number of capabilities around Couchbase to get early insight and access to Couchbase experts within the company itself. So it's a really good program. So if you speak to Laura or any of the other Couchbase team, they'll be able to tell you more about it if it's something you're interested in. So a little bit about Seenit. I'll describe what we do and why we do it, and then that'll set a little scene as to what we're doing with search. So it was founded about 2.5 years ago by our founder, Emily Forbes, in London, and we provide a new production model for companies like Rolls-Royce, Red Bull F1, and it's a new way of doing internal communications video. So we're powering a revolution within large enterprises that want to hear voices from their employees who don't normally get heard. So it's anything from internal comms videos to branding, broadcasting, marketing, and fan engagement. So we power BT Sport's fan pundit program. We also power BBC Earth's community programs, and we've done some really interesting things with Rolls-Royce where they're covering a lot of their launches of new engines and so on. And from a technology perspective, all of that is running on Python. We're entirely 100% Python, running on the Cherry Pie framework, and then we use RabbitMQ a lot for our asynchronous tasks. And all of that runs on Google's cloud platform. We are built from the ground up with Couchbase, and what we typically do is our CI and development environments will run the latest developer preview or beta version, and we'll be developing new features against those so that as soon as the database goes GA, our features go live with that. So we've been doing that with full text search. We did that with NIQL last year when NIQL was released, and we found it a really good way as a small team and a small company to push what we're doing and gain advantage of the developments that Couchbase are doing. We can take advantage of those straight away. And we're currently running a 6-node cluster of 451 in production. So how does it work? We have a mobile app that runs on iOS and Android, and we use that to capture content, so videos, photos, and that's all guided and directed in a live way by someone who sits behind a studio, so an online web-based studio, and they will ask their community, so whether it's an internal employee community or whether it's a fan community, they will ask them to shoot some video about what they're doing, where they are, who they are, what they're doing, why do I want to work for this company, what are the values that it extols that are interesting to me, or as a fan, what have I thought about the latest football match, or what do I think about how well my team is doing or a specific player. And then all of that footage gets beamed up into our cloud platform. It goes through then a number of asynchronous processes to analyze it, to transcode it. Video from mobile phones, especially if you're an Android user, comes in a variety of shapes and sizes. So we normalize all of that into a standard format that editors can then drag and drop into the editor of their choice. Or we have an online web-based editor as well. So what we do is we provide a script, and that script is defined at a project level. It's like a little mini film crew. That can be updated in real time, and then you can also send direct messages to users and say, that was a great shot, but there was a bit of wind noise. Can you do something about it? And then that gets sent into this online studio. So that online studio is designed to be managed by a non-technical person. They shouldn't have to know how to use complex video editing software to get this going. But we also do a lot with tracking and analytics to make sure that we know who the top contributors are, who do we need to call out to, who are good people within the community that we know are consistently going to deliver quality content that we're looking to push out. We can also share those clips out in a feed, and all of this is managed, all of this is run on Couchbase using NIQL, using manual key lookups, or using full text search. So to give you an example of the types of content that we're dealing with, we have our little showreel, which I'm going to play. And
are you filming?
Using Seenit today.
Solidarity with refugees.
I'm a nature photographer. What inspires me to capture the night sky.
Training time.
One step closer to Rio.
Keep watching.
so in there you saw a lot of video from the British Olympic team when they were in Rio. They were doing live videos and near real-time editing to get videos out to the sponsors and out to the companies that they were partnering with. But how can they do that when they're getting 50 hours worth of footage in an evening from 100 different contributors? How can they do that without having to watch every single clip? And nobody's going to have time to watch 50 hours worth of footage in just 2 hours. So we needed to come up with a way that was going to allow people to do that in a more efficient format. So it's just not an option to have all of that footage watched. Even if you had 100 people, you're still going to have to collate all of that information. And then if you then want to do a wrap-up at the end of the year or end of the week, you then got a large video library of maybe thousands of clips that you then need to look through and find out what, where the best bits are. And sometimes you only need 2 seconds of video to tell a story. It's just a face, it's a look, it's a movement that you want to look at. So we wanted to take the pain out of that. So given that we're collecting all of this video, we can look at what our current filtering capabilities are that you would get just out of having ordinary video metadata attached to it. So the immediate knowledge of that content that we have at the time of capture is things like the media type, is it a photo or a video? If it is a video, how long is it? I'm not interested in looking through an hour-long documentary that someone shot. I just want 15 seconds of someone showing something interesting. If I've got a script or a storyboard item, I can filter by that. It's just a number against it. I can filter by that very easily. When it was shot, when it was uploaded, anything else, any other dates that we might have. The name of the person who shot it. So if you know this person is a really good videographer or cinematographer or just has an interesting story to tell, then it's going to be something that you would want to search on quite frequently. But all of that really is not very interesting data. I mean, yeah, you can do stuff with it, but it's not. There's no insight into what you're doing. So if we want to look at things like objective qualities of video, so the exposure, the focus, stability, audio noise, all things that we might want to be able to derive from video, then those are things that we will need to have a think about how we're going to deal with and how we could search on them. But then there's also insight into content qualities, the qualitative qualities of a video. So what is the sentiment of it? What's their clarity of voice like? Can we understand what they're saying? And are we interested in what they're saying? So it turns out the answer is Skynet. So we use Google's machine learning platform, which is powered by TensorFlow, and there's a link at the bottom that you can go and see some more information on. So Google's machine learning platform includes a number of ready to use out-of-the-box processing tools for audio content and image content, as well as textual content. It's a fully managed service, and natively it talks Python and JSON, so for us it was a perfect fit. And to be able to pull JSON data out of a machine learning platform and stick it straight into a database that we just so happen to be running that uses JSON documents, it seemed like a good match. So we thought, we'll give it a try, we'll see what we can do with it, and experiment with the results. We can iterate on it. The advantage of a machine learning platform is it is a learning platform. So we can tweak it, we can work out what works, what doesn't work, and go from there. So how do we do that with video? Video is quite a complicated beast because of how much data there is in there. So we decided to make our lives a little easier for ourselves and just take a frame grab every second. So a frame grab will just take it as a photo, typically a 1920 by 1080 image, which is an ideal size for image processing. And then we process each frame grab as a single entity, and that will give us some data, which I'll describe later. But we then combine those results together. So over say a 10-second video, we've got 10 frame grabs. There might be different things going on in each second, if it's a pan, if there's a zoom, or if there's movement in it. And then each of those images will give us a set of data that will contain confidences about each tag or image that we might have in it. So let's say we've taken the top right image there. It's a windmill with some runners against it. Each of those will give us a confidence to say, okay, I'm 90% sure there's a windmill in that photo. I'm 85% sure that there are clouds and blue sky. I think that's grass, that's 70%. And then those look like people, but we're kind of not sure about that. And because they're moving through the shot, they'll get closer. We can combine those into a single bit of data and then increase the confidence accordingly. And again, because we're dealing with Couchbase, everything just gets stored as a JSON object, which is the native data format of this machine learning platform. So the quantitative analysis that we can do on videos like this will help our editors find well-shot videos. They will need to be correctly exposed. So that there is our founder. She took a photo to demonstrate how an underexposed shot will look. And we can immediately identify that that is an underexposed photo because of the machine learning platform that it's running through. We can tell if it's stable. We can determine if there's a stable horizon, and if that horizon moves. What do we know about that? You don't want to watch a video that looks like it's been shot like that. You want to watch a nice stable shot. And then also background noise. If you're dealing with someone who wants to have a shot, they might have music over it, so they don't care. But if you've got someone speaking, do you want to identify the fact that there's a plane going overhead and therefore not that usable? So again, if you've got hundreds of hours of this footage over maybe 10,000 individual items, to be able to filter that down much more quickly in this way is incredibly useful for our editors who just want to get editing. We can also look at other things like how was it shot? So is it a pan? Is it stationary? And identify that from the movement within the shot. And also we can look at dominant colors. So this is really just a histogram, but you can look at how, let's say I'm dealing with an angry theme and I want red, or a more calming, serene, verdant green. So object classification will help us take that even further. So rather than looking at how well the shot has been made, we can also define what is in the video itself. What are the objects in that video that I might want to show? It will help the editors find specific scenes. So either because they want some runners to run past to tell a little story, or they just want some filler shots. And then we can define the confidence of each of those objects within the scene itself. And if we wanted to, if we were dealing with something that was being edited by a community, or if the content was going straight into an unmoderated feed, we can automatically moderate offensive content as well, We've never had any, but we could if we needed to. But we can also do interesting things as well, like sentiment analysis. So we can tell if someone looks happy or looks angry or looks sad or surprised. So just by being able to say, right, I want happy people. I want to show happy people in my video. Then yeah, this is a great way to do it. And we can also perform optical character recognition. So if we know that there's some logos or labels in the background, we can automatically identify those. We will get a bounding box, and then we can blur those out if there are copyright issues. So as an example, we ran this through, and we got windmill, grass, green, sky, blue, and all of the things that you might want to search for within that individual clip. Another example is one that we ran with the Red Bull Formula One team. They were using us to film some behind-the-scenes candid videos of what their engineers do, what their drivers do behind the scenes that the Formula One management companies don't normally let you see. So they did this, they did a 10-minute documentary with all of this footage, but we ran all of their content through here, and I was absolutely quite surprised that it recognized it was a Formula One car, and that there was, it was open wheel, it was a sports stadium, human activity. I mean, there's people in it, so it's, yeah, who knows? But you know, those are the two, at the time, they were the two Formula One drivers, and yeah, they were getting great content for us. But at the same time, we've also got other customers who are using us in retail chains to identify when there is stock coming in that is, has been poorly delivered. So they might get a box of bananas, and they've all been split, so they have to send them back. So head office will then go back to that individual supplier and say, come on guys, this isn't good. So they can now search all of that content themselves and find the stuff they need. And then just as another example of what we were doing with the team in Rio, the British athletics team, yeah, we can identify individual sports, yeah, things that are going on within the scene. And then the sentiment analysis. This is where it gets kind of a little bit scary at times, but it's, this is Ed. He's one of our business development team, and yeah, he's looking pretty happy. He's got some facial hair and he's got glasses on, and the system just picked those up. So yeah, what if we combine all of this together and put all of this data into a melting pot, we can then say, okay, I want to find people who look happy, and then combine that with transcriptions, automated audio transcriptions. I want to combine that and say, find me people who are happy and say hello. So I can start off my video telling a great story with people who look happy. You know, if you're doing a longer form documentary, that typically has an emotional curve throughout a documentary or a film. And so you could take this a step further and say, right, okay, I want to fulfill this emotional curve automatically with all of my data. And here he is looking rather sad. He's not happy. So again, the next stage, audio transcription. So we can define what is spoken in a video. This will help editors find specific scenes. It will help them find the word position and time codes for that. So we can say, okay, I just want this bit of the video, and we can pull that part out automatically. Again, you can moderate offensive content, bleep inappropriate words. And then we can take that again a step further and perform natural language processing on that content and get some more insight into it. So when we do that, we can extract proper nouns. We can extract a prevailing opinion about whether someone's speaking positively, negatively, or neutrally about a topic. And we can tokenize as well. So in the same way that a full text search system works by tokenization, we can do that at this point as well. So as a working example, a transcription might look something like this. I really like working with Couchbase and enjoy talking about the work we do with it. So we ran this through the sentiment analyzer, and that said, okay, that's a pretty positive. So polarity 0.8, it goes from a range of -1 to +1. It's a pretty positive statement. Magnitude is effectively a magnitude to say, how positive is it? We know it's positive, but how positive? And then it's also pulled out the fact that there is an entity in there, and it's recognized and pulled from Wikipedia the fact that Couchbase is an organization, and the salience defines how important that proper noun is, that entity is to the sentence. So if you pull all of that into a JSON document and say, okay, we want to apply some NIQL to this and find out what we can do with it. So we've got this into a document that, as you will always see, is typically we've got a type, so it's a video analysis. We've got a transcription in there. We've got some visual objects. So in my case, face, beard, eyewear. We've got our sentiment that was shown previously. So what can we do with that now with NIQL that we might find useful? Well, first of all, we're going to pull it out. This is, as Brant was saying in his earlier talk, this is your bread and butter query to say, okay, I'm just going to pull all of that data out. But then if I want to find positive, or reasonably positive statements, then I can look at adding a sentiment.polarity. So polarity is the key within the subdocument, just greater than 0.5. And that will pull out everything that looks like a positive attitude that someone's talking about. But then if I want to find those happy people, and there's a definite face in the video, then I can just add an array search in there. So any tag in my visual objects satisfies any one of these tags. But then if I will then also find around the same query but around a specific organization, so I want to find people who are happy with Couchbase, then I can add, it gets a little bit more complicated, but you can then do this sort of query to get an idea of who's talking about an organization, and that organization is Couchbase. As you scale this up, you can imagine that as you add more and more data, this type of query becomes more and more complicated. It becomes much more difficult to deal with things like the transcriptions, where you've just got a text string. It's unstructured, effectively. So, whilst we can do field like partial, like is case sensitive. Though I don't think there's an I like in NIQL. It does not tolerate typos, so there's no fuzzy searching. You can't say, okay, someone spelled Couchbase, but they meant they missed an O out or something. And you've also you have no restriction on stop words. So is, the, and, all of those small words that mean nothing in a sentence really, will always be included in there. But what if there was another way to do it? What if you can do all of that we've had previously with fuzzy searching, with prefix searching, with word stemming and boosting in just a few lines of code? So full text search offers a number of things that are incredibly useful for us. So there are several pre-built analyzers, a number of different languages that will do word stemming. So waterfall will stem to water or watery. So if I search for water, it will give me matches against waterfall. If I search for waterfall, it will also give me matches against water. There's a number of different languages supported. And you can also do fuzzy and prefix searching. So you can define how fuzzy you want it, and also have a prefix that will handle automatically word stemming and all of the good things offered for that. You also get, I think, as you would have seen in Perry's demo earlier on, result snippets and word highlights. So you can automatically define how the data comes back and say, okay, why did this result match my data? Why am I getting this one back? And so you will get in your transcription a fragment of that transcription with either HTML or other markup in there to say, okay, this is why. I'm not going to go into TF-IDF because it's slightly out of scope for this talk, but there's a link there. It's basically a way of saying how important is this word in this document versus all of the documents that I have. I'm going to go into more detail about conjunction, disjunction, and Boolean queries, but they offer some really interesting capabilities. And in 4.6, there is now custom sorting. So previously, it was always sorted on the TF-IDF score, but you can now define a field and sort on that automatically. And you can have boosting. So boosting allows you to run a number of different queries and say, okay, this one is more important, relatively speaking, to the other ones. So for example, I might say, if I'm searching for Couchbase, that will be more interesting in a transcription than it would be in a tag. And so I can boost that to say everything that where Couchbase appears in a transcription will appear higher in the list. And then faceting. And again, you would have seen this in Perry's demonstration, but there's a very cheap and cheaty way to get related searches using faceting. So development speed, this is the slide that the product marketeers always like. So we estimated to implement full search capabilities for content. So that is all of the stuff you'd seen previously, video content, tags, transcriptions, sentiment, and so on. Community, so all of our user profiles. We have across our community of all the employees, anywhere between 5 people within an organization to 250,000 people for some of the larger organizations that we deal with. So projects are the crews. Academy is our tutorial platform, so it's a way of teaching people how to shoot video, how to make good video. And features, so if someone searches for a specific feature, it gives them a quick way to access that rather than having to go into a menu system. So we estimated that was probably about 6 sprints worth of work to implement and test that. We actually developed, tested, and released all of those in a week using only full text search and Python. It actually took less than that. I did most of it in a weekend. But we wanted to make sure that the UX was good. And so the actual behind the scenes number crunching part was probably only a day and a half of actual development time. And then because we were doing so well with it and because we were so happy with how it was working, we actually then went and rebuilt built additionally a full autocomplete search with related searches attached to it. So the only hard part really was just knowing when to stop. We could have just kept going and going and going with releasing new features on it, but we've got other stuff we need to do. So to give you an example, this is within the BBC Earth platform. So BBC Earth are the guys behind Planet Earth and Blue Planet and all of those great nature documentaries. They have a very large community of photographers and videographers around the world who like to submit their content, and it goes into a combined gallery on bbcearth.com. And they use us as their platform to do that. And we ran, retrospectively when we built this, we ran all of their content back through the machine learning platform. And if you search for frog, you would hopefully see lots of pictures of frogs, and you do. And if it's probably a little small, but in the bottom right, you can see the time it took to do that search. 0.07 seconds to run that search across hundreds of thousands of documents within their account. And the predictive search, so this is where it's that typical little search that you would see at the top of a website or something. You start typing, and within less than half a second, behind the scenes, we've actually performed about 5 different searches, combined all of those results together, taken the top 3, and then returned them in a very lightweight JSON document that is then shown here. So how do you get started in using full text search in this way? So determine what you want to search. So are you searching across all of your documents within a bucket, or do you just want to search specific types of documents? So do you only want to search your user documents, or do you have other content that you would want to search? If you were building Perry's example that he was showing, you would probably only deal with your user documents, but you then might extend it later on. So you then choose the fields that you want to index. You're not going to want to index everything. It will just create an incredibly large index for you. You then create the index, and I'll show you how easy that is. And then you search. And then you also go to the full text search tomorrow at 1 p.m., which I think Will and Marty are going to be doing to get more details because they know far more about it than I do. So the types of query that you can run, there's a number of different queries. We use only a few right now, but we're going to be extending. So a match will perform a basic query match against the text you provide using the analyzer that you've specified in the index. And there's a number of different analyzers. Some of them will do word stemming. Some of them are keyword searches. So they will only match the exact phrase that you've given or match the exact term that you've given it. There's standard analyzers that will only remove stop words. They won't do stemming. There's a match phrase. So this will also do stop word removal and word stemming, but it is designed to handle a specific phrase. So you would have spaces in there, for example. So I might say green frogs, for example, and get green frogs. And then there's prefix searching, and this is basically your way of doing wildcards, or at least where the term starts with prefix. But there also is a proper wildcard. There's a Boolean, which will just match a true or false as an actual JSON entity in the document. There's regular expressions. There's a few others as well. There's date ranges and so on. But then there's also what are called compound queries. So compound queries mean that you can combine multiple queries into a single query and then run further analysis on that. So, for example, if you've got a conjunction query, this is the equivalent. If you're used to using Google, it's the equivalent of putting a plus in front of everything. So you say, right, okay, a conjunction query must match. The documents must match every query that I've put in there. So if I've got a match and a prefix, I can stick those together and say, okay, any document you return must match both of those. A disjunction query is similar, but you can specify n matches that are required. So you can say, okay, here's 5 match queries that I'm going to send to you. You can match 1, you can match 2, but you'll still be ranked accordingly. But it can be useful for all sorts of things. And then a Boolean query is also then something similar, but you can specify a list of musts, some shoulds, and also must nots. So that's quite a useful, I've got a demonstration of how that works later on, but it's quite a useful thing if you're dealing with multi-tenant data. So there are some tips around creating indexes. Typically you will have a type field in your documents. If you only want to query those documents, just disable the default type mapping that is in there, and then create a type mapping that matches your document type. So what that will do is it will say to the index, I only want documents of this type. So I only want video analysis documents, or I only want user profiles. And you would typically, the way we've done it is we create an index for each type of thing that we want to search, rather than having one index that covers everything. In 4.6, there is also document ID type mapping. So if you don't have a type field in your data, but you do have something in your document IDs that determines what the type is, then you can add that in there and it will work it out from that. So if all your users have user : user ID, that's the way to do it. You then basically create child fields for everything that you want to index. And then it's okay also to add multiple child fields for the same field if you want to use different analyzers. So as for example, we've done that a few times with tags, where we want to actually give a boost to an exact match with a keyword analyzer versus a stemmed analyzer. So if someone searches for waterfall, we can do actually a keyword and boost that so that waterfall match will specifically be higher than water. Although water will still match, but it'll be much lower down the field. So it's a good way to make sure that you're getting the results that your users are going to expect. So this is exactly that. You can also do some nesting of disjunction and conjunction queries, which is what we do, so that you can say, okay, it must match one of these, and optionally at least one of these. So in your Couchbase admin UI, you'll end up with something that looks like this. So this is where we've got an upload type, so a type upload which matches a video. We've got tags, and you'll see I've got that searchable as tag terms, and that's using the keyword analyzer. And we do that for search faceting. I'll talk about faceting later, but if you want to do facets on tags, then you will get some weird results if you're not using keywords. But then a hash is basically a unique ID. So that's also used as a keyword. User, we've got that in there as the default analyzer. So that just allows you to search a name. The transcription, again, it's just in there. And all of these are actually storing in the index itself as well. This is basically the equivalent of a covering index in NIQL. If you don't need to get the full document, then this will return it all. It's also required if you want to do highlighting and fragment returns. So what is returned in your data when you run a search? So you get a list of all of the document IDs that match, and you can limit how many are returned. You can do pagination very easily. You get a list of document IDs and their scores, their TF-IDF score, of how relevant that document is to the search that you performed. You will get where the matches were located. So if it's an array or if it's text, it will tell you where in that array or text it was returned. You will get any requested fields that are stored in the index. So whereas in NIQL you would do select and then the attribute names, you can actually request to have those returned as well. And then also you can get the highlighted fields separately if you wanted to. And then it will also return the total result count. So if you do want to do pagination, so if you've got 1,000 results and you only want to show 25, you can set a limit and an offset as you would in NIQL. But nicely, it will also return in the same result, the total match. So this is some basic Python code that matches similar to what we've got in production. We have a list, an array of match queries, and then we've taken the query string Q, we've split it based on a space. So if I search for Couchbase Connect, it's going to split that into 2 different queries. And then what we're doing is we're creating a number of different matches against that query to say, okay, I want to search prefixes for email and also for name, but name is more important than email. But then also if it's an exact match on either of those fields, boost it accordingly. So I can do a prefix and a match in one query and have the results augmented by score for what I want to see based on how important those fields are to me. So I created a disjunction query. So all that's doing is basically saying it must match at least one of these. By default, a disjunction query it has a requirement of just one. And then I just get my results. I specify the index name, the query, and any other parameters that I pass through. So the parameters that I can pass through are limit, offset, which fields to return, and whether I want to run any faceting. So if we want to do some more interesting things, we can combine disjunction and Boolean compound queries. And this is really useful for multi-tenant data sets. So typically, if you're running a set of data that you've got multiple customers sitting in the same bucket, you will probably have an account ID or some defining feature of your data to say this data belongs to this customer or this user. So I only want to match that client's data. So I can create a keyword, an analyzed field for a tenant's ID. So let's say it's a name. Let's say Couchbase is a customer. The Couchbase name itself is a keyword. So I can analyze that, and then I can combine that into a normal search. So let's say I want to search for Couchbase Connect content that is within the Couchbase account. So I create that as normal. So whether it's a match query, a phrase, or anything else. And then I combine those into a single disjunction query. I create as many term queries as I want against the keyword field. So if you were searching across one account or multiple accounts, or if you've got another type of grouping that you might have. For us, as an example, we've got our projects within an account. A project is a specific event or film crew that's happening. And we combine those into a single disjunction query. So we've now got 2 disjunction queries, one with all of our matches and one with our keywords. And then we build a Boolean query to say, okay, it must match these in the keyword disjunction query to get that data. And then it should match at least n of these for my matches. So faceting is another aspect of the data that you can get, and this gives you some, again, a great way to provide additional search capabilities within your UI. So we use it to create related searches. So if I search for cloud, I'll probably get other related searches like sky, sunset, and natural phenomenon, and so on. And what that will do is it will allow me to either give an option to further filter my data by those additional tags, or I can just say, hey, you might also want to try this. So if I search for frog, I will get a related search of amphibian, and then I can go on from there and just do additional searches. So it's just a really cheap way of doing related searches, but the quickest way to do it is just, as I showed you in the screenshot, just get an additional keyword analyzer on the tags you want to do. Fetch a term facet with your search. It's just a parameter you send through when you perform your search, and you'll get that data back. You'll get a limit of however you define, and then you can just pull out the top 10. So yeah, so that's all you need to do to get that data. And then those tags you just display however you want, and it will give you how many of those within that result set have that tag. So if I search for cloud, and let's say half of those, so I've got 100 results for cloud, 50 of those have got a sunset in them, I'll get sunset 50 in my data, and then I'll be able to show that to the user and either present it as an alternative search or an additional filter. So yeah, I will get that. So, as the demo gods have not been too kind for some people today, this is a bit of a risk, but we'll see how it goes. I'm going to take a photo, and I'm going to upload it into our online studio, and I'll send a few others up with it as well. So. I'm going to take a photo of here. You can wave. And so that's now uploading into our studio. It will get processed and analyzed. And then I will also upload, like any good Instagrammer, I had a turkey burger with avocado and took a photo of it yesterday. So I'll send that up. Took a photo of the sunset and the plane that I flew out here on. I'll send those up as well. So our first one has come through. So there you guys are. And we can see the tags, hopefully. We've got audience, convention, academic conference, seminar and auditorium. So now if I just search for seminar, our content is up there straight away. So the actual lag from the upload to the processing is usually within less than 5 seconds for us to process it. If it's a longer video, it takes longer. But then I can do what I need to do with that. As an editor, that's exactly what I need. Let's see if my other content has come through. I think there's a couple more still uploading. So here we are. Here's the plane. So we've got flight, airliner, aircraft, vehicle, aviation. So if I want to search for aircraft, we've got it there. So hopefully that has given you some insight into what you can do with full text search. It can be a complicated topic. It doesn't need to be. I'm not an expert in it by any means, but I managed to get it all done in a really just a few hours over a weekend. The documentation is excellent, and the guys tomorrow, I'm sure, will give you a very good, more detailed presentation on exactly how to do it properly. So thank you very much. If there's any questions, I think we've probably got.
That upload was fast. How do you trigger upload complete and then start your pipeline to do the extract?
So that's really where RabbitMQ does a lot for us. So what happens in the app, we will upload to a secure location. So the app will request a signed upload URL that is unique to that upload. When that is completed, it will then make an API call to our server, which then will trigger about 5 different asynchronous processes that run in parallel. So the system will actually scale up automatically depending on demand. It just adds new servers. And so it runs all of those operations in parallel. And then because we're just writing that into a Couchbase document, all of those are done as single mutations against the document, which are then picked up behind the scenes by DCP, the Database Change Protocol, sent off to all the indexing nodes or FTS, and then made available very, very quickly. So yeah, the actual lag is quite minimal. The biggest delay is uploading the binary.
So the upload happens and then the client, your phone, doesn't hook to a API.
It basically says, hey, yeah, here's some information.
Is that, you mentioned earlier that there was a 6-node cluster.
Yes.
Do you run FTS on each node or do you have a dedicated FTS?
No, FTS is still developer preview, so we're being a bit naughty by running it in a production environment. So we run that on its own machine. So we have 3 data nodes, 2 query and index nodes, and then FTS is its own machine right now. I don't know how that's going to scale in the future. We're just going to have to see. Matt, did you have a?
The terms, they were in relevance order after it was processed, because then it was parallel.
They are, yes, they are, I think. I'd have to check. So we receive back a confidence value, and then we actually receive more than we usually store. And then we have a threshold function that says, okay, I only want something that I know is relevant because I don't want that to be tagged as a baby. And sometimes it does get it very wrong. So we have a threshold function that just says, okay, only cut it off after this point. So you could still get back a number of tags, but those I think are in there in confidence order. Yeah.
Did you compare the solution with other search engines like Elasticsearch?
We did, but we're a really small company. When I joined, there were 3 of us. We're now 18, but only 5 of those are developers, and only 2 of those, and 1 is me, are Python developers. And I also do all of the ops for the company. So to run another node or to run another platform like Elasticsearch would have meant more sleepless nights for me. It was something that we knew we wanted to do in the future. I knew that Couchbase was looking at FTS, so we just waited until that came along in the developer preview, went into development mode on that, and we got it out very quickly. So not having to run additional platforms just makes it easy. It makes my life easier, basically. But I'd used Solr and Lucene previously, and so I knew what they were capable of, but I just wasn't interested in managing them. Cool.
Does it come with the
Sorry.
SDK or something like that for doing the index search?
Well, the actual, so we use, I don't know what the other SDKs are like, but the Python SDK has all of those built into it already. I think Java does, all of them do already. So yeah, it's already handled by the SDKs, and it's as easy to use as all of the other SDK components. It's really, really well documented. Do you have it? Yeah.
For the sentiment analysis, do you transcribe all the audio and then store that in FTS so you can search the full transcription as well as the tags?
Yes. So if there is a transcription available, we will store that as just a string in the Couchbase document of that video, and then make it searchable. The transcription is probably the hardest part to get right because the audio from these is not always great. People have a tendency to record like this and cover the microphone, or there's background noise. And so we've found that that's probably been the hardest part for us to get right, but it's getting better, but we just need to understand like how to improve it. No, we actually use Google's speech API. So that, again, that runs on TensorFlow, and it's a fully managed service, so we don't have to worry about too much. We can just send them a FLAC file that we pull out from the video, and then they manage it on their end. And they give us, again, confidences of those words.
Is that a subscription service?
It is paid for, but I think up to a point it's free. So yeah, you can give it a try if you want to. Same with the Vision API.
So then, like in the Red Bull picture, like, you didn't have to do any training for TensorFlow?
No, and this is the advantage of using a platform like Google's Vision API, is that they've already pre-trained it. You know, it's the same platform that they use for Google Image Search that stores all of those. So yeah, we would have to do training if we were doing other stuff, but you know, all of that is free and out of the box. So it's a good way to get started. Cool. Thank you very much.